types of sets. So we are going to look at 7 main types of sets and then 8 class of sets. So we have finite sets, infinite sets, unit sets, null or an empty set, universal sets, equal sets, equivalent sets, and then each class of sets is going to be special types of sets. When we talk of finite sets, what we mean by a finite set is a set is said to be finite if the last number, member, a set is said to be finite if the last member or the last element is known. For example, if we have a set A, 1, 2, 3, 4. In this set, the last element in the set is 4. We know it because we know the last element of the set. We say the set is finite. The next type of set is an infinite set. An infinite set is the inverse of a finite set. What we mean by that is an infinite set is a set whose last number is not known. So for example, a set B equals 1, 2, 3, 4. So we have the set B equals 1, 2, 3, 4, and then we have 3 dots at the end. What these 3 dots means is that the numbers run up to infinity, which means it can go 4, 5, 6, 7 up to infinity. So we don't know the last number. So in this case, we refer to this set as infinite. So you can see that it's an opposite of finite set because we don't know the last number here, but we know the last number here. The next type of set is a unit set. We say a set is unit if it has just one single element or a member. So for example, we have set Q equals set Q equals A. The set Q contains just an element A. Because of that, we say Q is a unit set because it contains just one element or member. Don't get confused with this. If you have a set A which is equal to 0, this is also a unit set because 0 is a number. So don't get confused because 0 is like nothing. So you say because it is 0, it's not a unit set. 0 is also a number. So in this case, set A is also a unit set. So let's go to the next type of set, that is null set. A null set or an empty set, as the name suggests, is a type of set with no element or member. So for example, the set B equal just an empty curly bracket. So what it means is that set B is a null set because it has no element or member in it. Don't also get confused with this set A. A equals 0. Don't say because 0 is nothing, it's an empty set. 0 is a number, so it contains one element, so it's a unit set, not an empty set. So the next type of set is a universal set. The universal set, we can say a universal set is a mother set, or like it forms the whole umbrella of what we are talking about. Oranges, and mangoes. If we are talking about oranges and mangoes, these are the subjects we are discussing. So we are talking about a set that contains oranges and mangoes. The universal set of this discussion can be or would be fruits, because oranges and mangoes are fruits. So the universal set is like the greater set, which contains all the elements or all the various aspects that we are discussing. So that is the universal set. So for if we are looking at a Venn diagram, the universal set of the Venn diagram is represented by a very big square with all the various parts inside. We will get to Venn diagram later, you understand it. So it's like the mother set, which contains all the various aspects of the various sets that we are discussing. Okay. The next type of set is equal sets. When we say two sets are equal, if two sets are equal, which means they contain corresponding elements or members. So for example, let's look at these two sets, A and B. Set A contains A, B, C. Set B, on the other hand, contains B, C, A. So in sets, the way the element has been arranged doesn't matter, but then what the set is contained is what matters. So looking at set A, contains A, B, C. Set B contains B, C, A. But then they contain corresponding elements, which means you can find A here, you can find A here, you can find B here, you can find B here, you can find C here, you can find C here. So since all the elements in A can also be found in B, it means set A and B are equal. So we can say A equals B. So if these two sets are not equal, then we can also say A and B are not equal. So that is the symbol for not equal to. Okay, so based on the knowledge we have from equal sets, let's try and look at these. So let's look at this example. So if set kill equals 1, 3, 4, and 9, and set R equals 1, X, 4, and 3, where Q equals R. Find X. So looking at this example, we are saying that we have the set Q which contains this element, set R which contains that element, and the question is further telling us that the set Q is equal to R. From what we just learned, we know that if two sets are equal, it means they have corresponding elements. In other words, the element that is in one set is equal to the element in the other set. So let's try and use this knowledge to solve for this question. So what we do, we try to cancel them out. So we have 1 here, there is 1 here, we have 3 here, there is 3 here, we have 4 here, there is 4 here. The only thing left in set R is X, and the only thing left in set Q is 9. So in this case, we can say that because Q is equal to R, X is equal to 9. So we can clearly see that if two sets are equal, it means the elements are corresponding or they have the same element. So we can use this to determine missing elements in two equal sets. Okay. So let's look at the last major type of sets. That is equivalent sets. When we say a set is equivalent, it means the set has the same number of elements. So number, circled number. So for example, we have set P equals 1, 2, 3. We have set Z equal A, B, and C. So let's look at the number of elements in set P. So from our previous lecture, you know that if you're writing a number of a set, you have small letter n into bracket the set. So the number of elements in set P is 1, 2, 3. The number of elements in set Z, which is given by B, is equal to 1, 2, 3. So because the number of elements in set P is equal to 3 and that of Z is also equal to 3, we can say that set P and Z are equivalent sets. So based on this, it is so obvious to be able to distinguish between equal sets and then equivalent sets. So let's look at the 8th classification of a set. And we have classified this type of sets as special type of sets. So this is a special type of set, and it's a collection of various type of sets. These are special type of set because this type of sets are a collection of sets that we use a lot in mathematics and in sets. So anywhere in maths you come across this type of sets, they are used in all forms of mathematics and calculations. So we have even numbers, odd numbers, prime numbers, natural numbers, whole numbers, multiples, multiples of numbers.